All right, let's take a look at the most missed problems from the first calculator multiple choice set. So the first one says the base of a solid is the region R enclosed by those two graphs. If each cross section of the solid is perpendicular to the x-axis, now right there we're here cross section perpendicular to x, that should tell us it's dx. All right, when we're perpendicular to the x-axis, we're dx. When our slices are perpendicular to the y, it's dy. All right, then it says the cross sections are a square. So we always want area of the cross section times the dx. So area of a square is a quantity squared. All right, so right there we can actually knock out three answers because they don't fit that structure. All right, and that's the first three answers. So we're down between the bottom two. All right, now on the inside we're going to want to find the gap between the two functions. It's quantity squared, so it really doesn't matter whether we do 2 cosine x minus ln or ln minus 2 cosine. It actually ends up that the ln is on top, and if we look at our answer choices, we see the ln out there in front. So I'm going to go ahead and subtract it in this order. Now, we're typing a cosine into the calculator, so you want to do a quick radian check. Since you're taking this at home, you're not going to have somebody in the room that does the friendly reminder at the beginning, like, hey, turn on, make sure your calculator's in the radian mode. It's not going to happen, so you're going to have to remember to check that yourself, especially if you're taking the physics test on Monday, because your calculator's probably going to be in degrees for that. So then when you switch to calculus, you need to make sure you switch to radians. All right, now from here, we have two choices that kind of meet this. Both of them start at 0, and they both go up to a 1.141. All right, one has a 2 in front and one doesn't. So our gut instinct might be to choose D. All right, because we're like, well, that area doesn't need to be doubled. All right, so we want to look at the graph, though, to confirm. So we're going to go to the calculator, and I've got the two functions typed in there. I'm going to quickly hit mode and just make sure I'm in the right mode, which I am. All right, and I'll go to y equals. Window, our x bounds were 0 to 1.4 something. So I'm going to go ahead to window, and I'm going to make sure the x max is further than the 1 point something that we had, so 2 is fine. Now, just to make sure that we don't have symmetry that we're missing, I'm going to go a little further in each direction. So I'm going to go back, and let's actually take this so we could double it. We'll go out to 3 on x max, and then just so we see both sides, I'm going to do a -3 here. All right, now the height being -3 to 3 is fine because the function was 2 cosine x. So the highest that can be is 2. All right, so we'll graph and see what we see. All right, so here comes our first graph. There goes our second graph. And now notice that we have symmetry in this one. So we have a symmetry between the two functions. So the integral they gave us, let me pull this over here so we can see it. They gave us an integral that gives us this area. Clearly there's two sections of that enclosed, so we are going to have a 2 in front, and the correct answer for this one is E. All right, so the correct answer for 85 is E, going through setting up for perpendicular cross sections.